Having talked about Skinner and his behaviorist perspective on how we might be acquiring language, when we talked about a little bit about how the theory itself works, and then some evidence that we have that might support that theory, as well as the large number of things that end up going against that theory, leading us to conclude that while, learning might play a component, or at least the behaviorist view of learning and operant-like conditioning might definitely play a role in some of our language acquisition, it isn't sufficient to explain all of our ability to acquire language on its own. So, what's our alternative, or what are some of the other ideas as to how we might acquire language? And so, our second person of interest is going to be Noam Chomsky. And Chomsky is known for the nativist theory of language acquisition. And so our nativist view says that language, or I guess language learning specifically, is best explained by innate, inborn, biological mechanisms, rather than some sort of external experience with your environment. So Chomsky went ahead and said that we as humans have a universal grammar. He described this as a collection of different processes, different mechanisms, we can say, that would help facilitate language learning. Specifically, stuff that would come from some kind of biological inborn predisposition. And all of this comes from the argument that brains should have evolved to produce language. So if we look at natural selection and all of the potential benefits of being able to produce language, to share information in that way, we can kind of frame it as an evolutionary benefit. Language production being an adaptation, and having the ability to facilitate learning that language could absolutely be something that would have a selective pressure for it. And of course, if you've known anything about Noam Chomsky and his nativist theories, you might have heard of the famed LAD, or the language acquisition device. And this is just the name that he gave to those theoretical processes or mechanisms that underlie our ability to acquire language. So one really important thing to note here is that we're saying, okay, the argument is there is some biological mechanism that we are born with that allows us to more easily acquire language. But we are not saying what that mechanism is. We are not saying where it is. We're not even sure how it works. If you delve deeper into some of the theories here, when we talk about this language acquisition device, we might have some theoretical discussions on, say, frameworks for all of our different language rules. Things like, does the verb go first or does the noun go first? And there might be, say, a switch where for some languages, depending on what you are exposed to, you will learn the rule one way. Whereas if you are exposed to a different language, that causes that theoretical switch to flip in the opposite direction, and you learn it the other way. The universal component is the fact that there is a rule that determines the order of different types of words when we put them together, but we're acknowledging that there can be flexibility between different languages, and with this idea of a built-in framework to help us, sort of like a scaffold to build our language on top of that innate component, we basically can think of them as switches. And yes, I'm aware that this is all still very, very abstract, but such is the nature of this theory, in fact. And it's one of the reasons why people don't necessarily love this theory, is because it is very theoretical. And while we might have some evidence, and we'll talk about that, for why we think there is this innate biological component to our language learning, if we haven't pointed out or proposed where exactly these mechanisms for learning are, or how they work, or anything like that, it becomes very difficult to find evidence sort of in support of or against this particular theory. So the theories that'll come after this end up trying to be a little bit more specific in terms of the natures of those mechanisms. And as per usual, when we think about, well, what came before this theory, with Skinner and his very precise explanation of exactly that operant conditioning mechanism and how it might facilitate learning to say the right things when you get positive feedback and learning not to say the wrong things when you get punishment, here it's a lot more theoretical and a lot more abstract. But definitely still worth discussing, because Chomsky is, in fact, to this day, still one of the largest and most well-known figures when it comes to language acquisition. So with all of that sort of tangentially related discussion of the background behind what people might think of this theory and the fact that it is highly theoretical, what are some of the pieces of evidence that made this so appealing at the time? One of the biggest ones is the existence of critical periods. So you've probably heard of this before, where we have this sort of window of time in which we are set up or primed to acquire language, where we see that rapid burst of learning with children, where they're going to start acquiring lots and lots and lots of words every single week. And they have this sort of sponge-like quality where they absorb that information very rapidly. But that window can close, where if you don't learn language within that window, then you have issues with language production in the future. So here we can look at things like children who were, say, the stereotypical raised by wolves, or in very abusive situations where they weren't interacting with adults, weren't hearing language produced. If they are returned to society and exposed to language about before puberty, puberty is usually the cutoff. So sort of that 11 to 12 years of age. If they're returned to society and exposed to language before puberty, they're usually able to successfully acquire language without too many detriments. Whereas if they're found and returned to society after puberty, it's now outside of that critical period, and you typically find that they struggle to produce normal language. So they might not be as fluent. Their speech would not be fluid and flowing. It would be a lot more abrupt and harsh and more difficult to plan out. And so Chomsky and others point to this critical period, saying that, well, this is showing us this biological constraint, where before puberty, we have that flexibility, that room for plasticity, flexibility, whereas after puberty, we've stopped, we've cut off your ability to then learn in the same way. And there's a bunch of really neat studies that look at like time periods in which you're exposed to language. And things like if you look at, say, learning a second language, if you learn it before puberty, then that information typically ends up integrated in the same primary language areas that your first language ends up in. Whereas, say you decide in your, say, 20s or 30s that you want to learn a second language, learn something you've never heard before, well, when you're learning that language, you end up storing it somewhere else. Meaning that if you're trying to use that language, you almost have to filter it through your primary language to be able to produce it fluently. Whereas if you learn before puberty and it's in the same area as your primary language, you end up being able to use the two almost interchangeably. And there's some fascinating studies looking at brain activation when people speak different languages, depending on when they learned them. Some really, really cool studies that look at things like, well, what if you learned a language as a young child and then moved somewhere where you no longer use that language? You actually still see some activation in response to hearing the language, even if you no longer speak it. And that kind of gives us the idea that that early experience, that early exposure, maybe some of those switches that were flipped early on, are still going to be producing that lasting change in how our brains work when processing language. So once we've learned that maybe these phonemes are really important, even if they stop being important, once they've been flagged as essential, they're integrated into the way that we process language. So all of these studies give us some evidence that, yeah, there's probably some biological component here, and puberty ends up being this sort of important cutoff point between sort of easier language learning and more challenging language learning. Though, if you're looking at what's on the slide here, we've made a note that While Chomsky originally proposed that we had these critical periods, something like a window with very harsh cutoffs, it was presented more as a if you don't learn language before puberty, you will not learn it. But in more recent years, they've kind of backed off on that, thinking that a critical period with a harsh cutoff is actually too extreme for what we tend to observe. So instead, we'd say that a sensitive period is actually a more accurate name for that time frame, where yes, it's easier to learn before puberty, but it isn't impossible to learn after. It's just more difficult. So we wouldn't call it a harsh cutoff, but more of a sort of a gradient of difficulty, where after that window, it's just harder, but not impossible. And like I've been saying, like we have some evidence for and against different theories. The concept of those critical periods gives us some support for some biological component here to language acquisition. What other concepts or other existences in how we learn language also add support? We have a couple here, and mainly, once again, we're going to be looking at similarities across multiple cultures and across, therefore, multiple languages, where the logic being that if we start seeing consistencies across most, if not all, human cultures, then it is very likely that those traits exist because of something that is innate to being human. Because if every culture is showing some similar pattern, and if not all cultures are able to directly interact with one another, then the existence of consistency must come from something other than social and environmental components. So our logic being, the more equivalence we find across cultures, the more sure we are that it's going to be having some kind of innate inborn component, which is our core tenet for this nativist theory. So, if we look for these similarities across different groups of humans, across different languages, what tendencies do we see? Regardless of the culture, children almost always learn nouns before verbs. So they are a lot better at naming things than describing actions. And like I said, across pretty much every culture they've been able to study. We've also implied that there tend to be some pretty consistent rules in terms of grammar. So we have rules that determine the orders and combinations and changing of tenses and things like that. And we find that while the specific rules may change, as I've mentioned, you might have verbs before nouns or nouns before verbs, but the fact that all languages are going to have nouns and verbs and rules about how you combine them, that tends to be universal. So the specifics can change, but the overarching ideas tend to stay consistent. And that's what Chomsky had latched onto to point out as those switches that could be flipped, where all of the different possibilities that exist across human cultures are all of the different positions your switch can be in. But yeah, overall, we see pretty minimal variation in the existence of those rules, which is really neat to see. And our last point here talks about the default tendency of gestures, where there are certain movements that tend to sort of automatically occur as we are communicating, as we're speaking. So you can think of this as people are very likely to talk with their hands. Some cultures maybe more than others, but even something like, I guess, pointing for something that you're asking for, or the grabby hands that I think I've mentioned before for children asking for something with gestures. We start seeing some consistencies within different types of gestures that tend to pop up over and over again. And again, if we take that step back, the fact that we are just always likely to combine verbal components and gestural components while communicating, that consistency implies there might be something innate to that quality as well. And this is, of course, not an exhaustive list, but a couple of things to consider that made us really keen on at least looking at the nativist theory. Like I said, our usual limitations of if we haven't actually talked about what the LAD is or how it works or where it's located or anything like that, it's really hard to get proper evidence. But this is just saying that from what we observe across different cultures, we definitely can't dismiss the idea of there being some innate biological component. We just don't know the source of that or how it works or anything like that. So our two existing theories have been kind of the extremes. One saying it's all about our interactions with our environment, how we get feedback from our actions and things in our environment providing that feedback with Skinner. And then we have Chomsky coming in and saying, okay, no, it's actually internal, it's biological, it is something that is native and inborn. And now, unsurprisingly, I would hope, we're going to find a collection of different theories that fall somewhere in the middle. And depending on which sources you look at, they'll use a bunch of different terms. So one term that I've seen used is an emergentist perspective, saying that that's bridging our gap between nativist and environmental or behavioral approaches. But I think the term that's a little bit more common is actually interactionist. So that's what we're going to end up going with. But regardless of the term that's used, our perspective here, this interactionist theory, or collection of theories, I suppose, is just what it sounds like. It's an interaction between a bunch of different factors that influence our ability to acquire language. So here they lean into things like biological components. So this is looking at, so for maturation, as we go through development, are things changing? So our discussion about how our brains might be more prepared for language before puberty and less so afterwards, that would fall here. We could even look at neural development, and we might have mentioned already the fact that the human brain is going to continue developing and maturing until sort of our mid-20s. So we have those processes of gradual change with our neural connections. So we can consider those as well. We can also look at cognitive development. So if we're looking at this diagram over here, which is actually kind of a weird one to think about with all these multi-directional arrows, but if they're saying that those biological components as we mature and develop as time goes on, if that might relate to our language development, maybe through the presence of something like the LAD, but it can also then cause an influence on our cognitive development. So as our brain structures mature, the way that we think about things can change, but also cognitive development itself can then influence our development of language more indirectly. So as we think about things differently, we might talk about and communicate about things slightly differently. Maybe we start learning how to combine things. We start learning some of those rules. And all of that can then also relate to linguistic environment. Basically, what's happening in the environment around us. So one of our sort of special focuses here from these in middle of the road type theories, our interactionist theories, we're saying that the role of parents and others who speak the language around you isn't necessarily what Skinner thought it was, but that environment and the language that you hear and the feedback that you get does still play a pretty huge role. And if we look at things like the fact that when parents are communicating with their children who are in that language learning phase, they usually adjust how they speak. So they're usually going to enunciate more clearly or speak more slowly or make sure that they're, say, projecting their voice to be easily heard. All of those sort of conscious or maybe even unconscious efforts on the parent's side end up sort of giving the children the best ability to learn that language in the clearest way possible. And so our interactionists would care about those types of factors as well. And as sort of one little tie-in to, say, Chomsky's discussion about our language acquisition device, that LAD, when we start looking at some of those sort of social components about that linguistic environment, there was a proposal for a slight modification, or I guess an additional device, and they called it the LASS, L-A-S-S, and that is the Language Acquisition Support System. And that's another one of those abstract theoretical mechanisms, but it was actually proposed with the intent of not describing biological constraints like the lad does, but instead to describe how the environmental components, the social aspects of our linguistic environment, can actually help support the acquisition of language. So a way to try and frame things like how parents speak to their children, or the types of words that they use while speaking to their children, how those can play a role as well. Now, obviously, I'm keeping a lot of this still very, very vague and abstract because, as with a lot of these theories, they can each get into lots and lots of detail, but for our purposes, just acknowledging that this is sort of the scope of this field is sufficient. If you get into studying language and language acquisition, you can go into our interactionist theories, you can lean a lot more into cognitive components, you can lean a lot more into the social aspects. There are all sorts of other sort of sub-theories that fall under here. But like I said, we're going broad umbrella work for this lecture. All right, so enough with our abstract theories for a little bit. We're going to move on next and start talking about some of the actual physical locations. Finally, something a little bit more tangible. But we're going to talk about specifically aphasia, and then we'll delve even deeper into different types of aphasias and the locations and what we know and how we know it. But starting off, we'll talk about aphasia in general as the inability or difficulty in producing or perceiving speech. Basically, we're going to be looking at aphasia as when damage has occurred and it interferes with our ability to make proper language. So we'll look at two specific types of aphasia. We'll look at Broca's aphasia and then Wernicke's aphasia, one of which interrupts production of speech, one of which interrupts the perception and understanding and comprehension of speech. But both are going to be interfering with a pathway that's connecting all of our abilities to comprehend, generate a response to, and then produce that response verbally when having conversations with others. And our knowledge comes from two very famous case studies where we got to see that damage in very particular areas of the brain led to very specific sort of detriments in language production and perception. So Broca's aphasia was first described by Broca. He had a patient who he called Tan, which is quite insensitive because it came about because after he had head trauma, there was damage to part of his brain and he was only able to say the word tan. So they called this Broca's aphasia because it was interfering with that language ability, and it was Broca's description of this. After Tan's death, they realized that there was extensive damage to this very specific area of the brain. And just a brief refresher here, because I will have many, many images of the brain for us at different points. But if we actually look at some of these lines, I just want to draw in where our different lobes are. So this here is separating our frontal lobe. So towards the front of our brains, this is where our eyes would be. That's totally an eye. So our eyes are towards the front, and this is looking at the side of our head. So our ears would be here. This section, if we actually follow some of these shapes, this section here is our temporal lobe. So that is under your temples. So that's your ear, definitely an ear. And then towards the back, we have this section here. This is our occipital lobe. Our occipital lobe will actually be what we talk about when we talk about vision later on. So we have our frontal lobe here. We have our occipital lobe towards the back, temporal lobe under our temples, and then I always know then that the last one is our parietal lobe, and that's going to sit sort of at the top towards the back of our heads. We will be using these terms a lot over time. So right now you don't need to memorize all of these immediately, but these are concepts that are going to keep coming up. So it might be a good idea to start familiarizing yourself. But yeah, you'll see a bunch of these diagrams where they're divided up a lot cleaner than just me doodling on my screen. But this does allow us to see that we have sort of our ears towards the side here. So we're going to have in this area our primary auditory cortex, where our incoming auditory information is going to be projecting, meaning that's where it arrives first, and then it gets processed in that area. And then towards the front here, we have Broca's area. This is the area that was damaged in patient tan. And the important part about this area is that if we follow this one sulcus, this bump, right in front of that division between the frontal lobe and the parietal lobe, this is still in our frontal lobe, this sort of strip here is our primary motor cortex. So that's the part of our brain that's going to activate when we are sending out motor commands to get our bodies to carry out some action. So here we're saying that, hey, this Broca's area is awfully close to the part of our sort of primary cortex that produces movements. And specifically, this area down here, right next to Broca's area, this area controls how we move our mouths, our tongues, our lips, even the way that we're breathing and our throats are moving. So this would be the part of our brain that's pretty closely related to how we would form words as we're trying to speak them. And I think I've mentioned before, but I definitely will repeatedly throughout the course, that areas that are close together on the brain tend to end up sharing some sort of functions and things like that. So the closer they are together, it kind of makes sense that they might be closely related in terms of functionality. And so what we'll start seeing is that this Broca's area would take information that was coming from the, say, the words that we're hearing. We're having a conversation with someone. So sound is going to come in through the ears. It's going to get sent to our primary auditory cortex, that processing area. We're going to decide what we do with that, send our decision of what intent we have to Broca's area. And that's going to say, okay, here's how we would make those sounds. Let's send out the command. But if we have damage here, part of that pathway gets broken and we're not able to form sentences, form words the way that we intended to. So that's one of our sort of proposals as to where that damage is occurring and what part of the pathway it's affecting. But yeah, if the visuals help for you, this is a good way to understand that. As I said, we will do a lot more of these diagrams, so you don't have to know all of this right now. I just find that, especially where you can't necessarily see me gesturing with my hands as to where certain parts are when we look at these diagrams, maybe the doodles will help for those who are visual learners. But yeah, so this is the area that was damaged. That's why we think it's involved in that production of language being a problem, trauma to that lower front temporal lobe. And this is actually an area where if we look at patients who've had strokes, if they have damage in this area, there is that tendency for it to affect their ability to speak in the future. So from all of this, we get two big take-home findings. The first is that there seems to be this area of the brain that controls speech production. It was actually one of those early pieces of evidence that spurred people to believe in sort of localization of functions within the brain. So they thought that, hey, if this part of the brain does processing or production of words, and this part of the brain is responsible for that other behavior, then maybe different areas all have different functions, different purposes. And that ended up being sort of around the same time that things like phrenology, there we go. Phrenology was that study of what all the different sort of bumps and shapes and sizes of our skulls could tell us about our intellectual abilities, linking the idea that, hey, this part of the brain has this function, therefore we can make some predictions. But as I kind of hinted already with my doodles on the screen, there's a lot of different moving components. There's a lot of movement of information between different areas. areas. So while yes, damage to that one area, that one spot is what was linked to that inability to speak normal language after that fact, damage to a couple of different areas could be involved in that whole process. So the Broca's area was important because it's part of that chain. We'll keep that distinction in mind. But the other really cool part, and again, we may have mentioned this before, but we should know by now that our brains exist as sort of a mirrored pair of halves. So we have our two hemispheres, the left hemisphere and the right hemisphere. And what we were looking at in our diagram, hopping back once more, so if this is where our eyes are towards the front, and this is the back of our heads and our ears are here, then we are looking at the left side of the brain. So this is the left hemisphere. And what we typically find is that damage to just that left hemisphere's Broca's area usually causes impairment of language. However, similar damage in the right hemisphere doesn't tend to cause the same kinds of damage. So someone can have, say, a stroke in that specific area, but on the right hemisphere, and have no impairment to their language production. So it tells us that language production seems to be controlled by our left hemisphere. We're going to find eventually that this is due to something called hemispheric lateralization. And that just means that our hemispheres, rather than both being equally good at something, we'll often see that one hemisphere will specialize in some ability and the other hemisphere will sort of free up space and get good at something else. We don't need the redundancy of both hemispheres being really good at something when just one being good at it is sufficient. Kind of like you'll see lateralization with things like handedness. So if you are right-handed, then it means that your right hand, and actually technically the left motor cortex that controls your hand, is going to be specialized. And your left hand, which is controlled by your right motor cortex, would be less precise, might have less area devoted to those controls. So we prioritize, we make the most of our available resources, and we specialize. So in this case, language tends to be lateralized into that left hemisphere. So I always remember language on the left. And we will eventually discuss the fact that not everyone has as extreme lateralization. Some individuals have a lot more dispersed language control, but we'll come back to that later. So two big important things here is that this part of the brain is involved in that process of producing speech, and it's all in that left hemisphere. So it tells us that it's specific to one hemisphere over the other. And so this is all talking about speech production that's causing problems. And as promised, I said we'd talk about two different types of aphasias. So we did Broca's aphasia first. Wernicke's aphasia is very different because it's in a different part of the brain. So same basic image. Unfortunately, my text goes right behind here, but I'll say it out loud, or you can move the image around on your own slides if you'd like. But same component here, but if we looked at it, we had Broca's area was towards the front here, and Wernicke's area is towards the back there. And so in this situation, similar idea, Wernicke is one of our researchers, scientists, who had a patient who had issues producing speech that made sense. So here, they were able to speak fluently, but what was produced was nonsense. And this was tied to damage to that temporal lobe. So remembering that that's sort of our temporal lobe in those lines. And this line would be that division between our frontal and our parietal. And that would be our occipital if we still wanted to do that, just for orientation purposes. And once again, we'd see, okay, well, Wernicke's area is awfully close to where our auditory information is coming in from our ears. So yeah, this is called Wernicke's aphasia or fluent aphasia, simply because they're still able to make words. It's just that the words aren't making sense overall. So they're not put together in a comprehensive way. They don't match to the conversation that's going on. And so this is telling us that this area must be linked somehow to speech comprehension. And that's what's behind here, is just speech. So this is how we would interpret those sounds coming in and assign meaning to them. So someone has said something to me, what's the meaning behind those words? Let's generate a response and then reply. If you have damage to that area, then you're not able to reply. You're not able to sort of add meaning to what you would say in response. So we've had some kind of interference with speech comprehension. And like I was saying before, when we look at these two areas, we have that incoming auditory information. So it comes into this primary auditory cortex. There's usually when we look at these cortices, you'd have sort of that primary projection area. And then as we get further and further out, we're going to be processing that information more and more. So we start making associations, including things like, okay, this sound was produced. I'm hearing this sound. What does it mean? And maybe somebody has asked if you want coffee because they're going to go and get coffee and they want to know if they should get you coffee too. So you have to hear the sounds, assign those to the words and what those words mean, and then you take that meaning and go, okay, so they've asked if I want coffee. I can think about, do I actually want coffee or not? You can say, yes, I want coffee, so I'm going to formulate a response. So Broca's area, I'm going to decide, how am I going to say yes? What words am I going to use? And how am I going to tell my mouth to move to produce those sounds into that primary motor cortex here? And then from that motor cortex, we send a signal down our spinal cord to make our mouths do whatever shapes we need to do to respond in the way we're supposed to respond. So these areas are all working together, where information comes in from our ears, we process it to understand or comprehend what's being said to us. We then formulate our understanding of that and our response that we want to make, and then we can produce our responses. So having damage to these areas gives us an idea of where in that process has been interfered with, whether it's in that production component of, can I formulate different sounds and words, or is it assigning meaning to the conversation that's going on? Those are our two sort of anchor points. And then everything else in between is just that flow of information as we go. And once again, I always just stress, yes, I like including these visuals because it helps sometimes understand how these things connect to one another and how stuff moves from one place to the other. But you don't need to sort of memorize, say, how to label this diagram for something like our midterms. I typically will not ask questions like that just because not everybody learns these locations very well. So more understanding that process, that movement is the important part. But if visuals help you learn that, then great. Our next couple of slides here are going to dabble into a couple of very different concepts than what we've been doing so far. This slide here is actually fairly redundant, I think, from how we've been talking about communication and how language is useful already throughout the earlier parts of this chapter. But if we want sort of this explicit statement of the different purposes of language, we could frame it as language can help us communicate thoughts and ideas and feelings. We'll see that things like, okay, well, thoughts, we can't necessarily infer someone else's thoughts unless we get some insight. So having somebody tell us what they're thinking can be definitely useful. Sharing ideas is really important, especially if we're looking at things like, what's the more effective way of doing this thing? For social communication, this can all tie in fairly easily. But when we're interacting with others, when we're forming relationships with others, we can typically look at things like better social interactions tend to lead to better communities, tend to increase things like survival rates within those groups, and so on and so forth. So having this sort of thing that helps us do that could be really important. It's more information than you need, but I find it really, really neat. There's actually a theory that looks at why we evolved language, or one of the reasons why we might have evolved language. And it's actually all framed around the existence of gossip. So, for a little bit of background, when we look at other primate species, a lot of this social interactions, a lot of these like group bonding exercises occur while engaging in grooming behavior. And grooming behavior is usually sort of one-on-one. I will pick ticks and fleas out of your fur, and then you do the same for mine. And that one-on-one gives you time to bond and interact and connect with others within your group. But as humans were getting into larger and larger social groups, if we sort of scaled up the amount of time that we'd have to spend to have that same level of connection with others within our larger groups, we'd end up spending 50% or more of our time in a day just interacting one-on-one with people. And so this theory proposes that instead of sort of having grooming be our primary method, we instead had a pressure for gossip, meaning that we stand around and chat and share information in an informal social environment. And the reason why this would be beneficial is because now instead of a one-on-one discussion, now you can have small groups. And they did a bunch of calculations about sort of how large social groups were and how much time we could afford to sort of spend on these frivolous social interactions. And it ended up working out really consistently, where we tend to socialize with groups of, say, 3 or 4, and that's exactly the number that we'd need to effectively make use of the time we could for these social interactions. But yeah, so language learning through gossip as a theory of evolution is a very interesting topic, but I figured I'd share because it's relevant here. But again, not something you need to know specifically for our class. But yeah, that was way more of a tangent than I intended, but continuing, our last one here is talking about abstract concepts and making those connections to the real world. And this one is very important because we were talking before about the idea of language allowing us a concept called displacement. So we can talk about something that isn't physically present. So I can tell you about dogs without having to bring a dog to show you that dogs exist. We can talk about that abstract concept without needing to see it presently. We can also talk about things that might happen in the future or things that did happen in the past. They are not presently occurring, but we can displace our understanding forward or backwards in time. And we can start talking about theoretical things. So this is really important for things like planning, maybe knowing that we're coming into winter and we should maybe adjust the kinds of foods that we're collecting. That would be an abstract concept that would be really beneficial to be able to discuss. So we can frame a lot of these potential benefits in a lot of different ways, and all of them show that language is a very flexible and potentially very, very beneficial thing for us to have. So there's tons and tons of, like I've shown, very odd theories about the evolution of language, but there's no shortage of different possibilities or different ways we can frame things. So hopefully I've at least introduced you to the fact that there is a lot of variety here. Our next section here is a little bit of terminology and looking at how we organize and store different words. And one of the important concepts here is called the mental lexicon. And so our mental lexicon is just how we store these words and the concepts that are related to these words. So you're going to look at not only concepts that relate to one another, but how they relate to one another. So I usually use in, say, my memory classes, I talk about a concept called priming, where when you mention a concept, it basically causes those neurons in your brain to fire. They've been activated. And that means that those neurons are then more likely to fire in the future because they have recently been active. So our brains have this predisposition to use them again. So if we're talking about the color red, and then a few moments later, I ask you, what is the first emergency vehicle that pops into your mind? You are much more likely to name a red emergency vehicle than one that is, say, white. So by activating a nearby concept, we have this almost cascade of reactions where the next concept gets activated because it was already sort of trickle down activated by something nearby. And all of that tells us that if we can see that these two concepts tend to activate one another in things like these, what's the first word that comes to mind activities, then they are probably stored close together in our mental lexicon. So the easier it is for us to associate these two concepts, the closer we think of them as being related to one another within this lexicon. And there's a bunch of different ways that we might propose that we construct these lexicons. We could talk about phonemes, so the sound components. So maybe we would have as neighbors based on phonemes, things like flea and tree and pea and glee, all of these rhyming words. They sound similar, so we would cluster them together. You might have more of a morpheme arrangement where we're looking at things like the smallest units of meaning. So these are, say, before and afters. These are prefixes and suffixes. And there's a little bit of overlap between our morphemes and semantics, where we get more into the meanings themselves, where we'd look at, say, synonyms. So I would say the morphemes are more like categories, whereas the semantics would be like, think about using a thesaurus. So a book and a novel and a tome would all get lumped in together. And this isn't saying that these are the only options and you have to pick one of them. This is just saying that these are some of the ways that our brains might logically store information depending on what makes sense to us. And from a lot of the research looking at different types of lexicons, different people will have different sort of preferences on how they store information. And you'll usually find this if you've ever played Pictionary with someone or charades, and you might have this idea of, oh, I can't say this word, so I'll use something similar, but it doesn't sort of register for anyone else. And that might be because in your mind, the two words were closely related, but for someone else, they are not related at all. And that can just come on experience or say prior associations or things like that. And this is that sort of fire truck example where we have in the middle, all of our colors are grouped together. So that might be something like we've grouped these based on sort of category of color, and then things that are red connect there. So we get roses are usually red, fire trucks are red, but then over here we have flowers. And red is also connecting down here to cardinals. And then there are more birds and things like that. So we have all of these different clusters of things that are related, either from sort of basic concept. So here we're not really seeing things like the rhyming words or things like that, but we are getting concept formation. And as obviously you can probably tell, we would have these get very, very complicated very, very quickly as we add more and more words to them. But this is sort of one way to try and visualize how that might work.